So we are going to play a short video in the background just while I do a little bit of scene setting for this particular project. We're going to take a look behind Scotland's National Retrofit Centre. The aim of this session is to really look underneath the build of non-domestic retrofit and how we, as a client, best approach that. The project has been a labour of love, not only for the BEST team, but also for all the contributing partners. And I can honestly say that this, without this team and without our very own Gavin Johnson, the project would not have been successfully realised. We acquired the building in 2021 with support from Scottish Government, with the ambition of making it Scotland's National Retrofit Centre. With no real availability of funding, we pushed along, appointing to have a retrofit assessment of the building carried out, which was undertaken by John Gilbert Architects, and that resulted in a three-stage retrofit plan with a very demanding client. I was just joking, Stephen. With an ambitious client, I should say. So no, like real excellent challenges that we were faced with. We then had that, you know, we had that undertaken that assessment, and we were kind of like, what's next? How do we approach this? And just towards the end of 23, SALEX, the Public Sector Heat Decarbonisation Fund was opened by the Scottish Government, which is administered by SALEX. We applied for it, a short time frame, and we were able to secure, Edinburgh Napier were able to secure 80% of the funds of the construction work, which resulted in 1.2 million. The project, unlike every project, didn't have come with its challenges from the outset, but we were able, as a result of our phase one, able to decarbonise the building, utilising Scotland's innovative construction solutions, low energy, low carbon solutions, but also allowing us to utilise this as an open source learning tool for everybody within the built environment, and on this trajectory to becoming an NRFIT certified building. So, but I'm sure you really want to hear about the project itself from the project team that have really worked really hard behind this. And Barbara, I just want to come to you first to ask you, how did you approach the project from a design perspective and the ambitions that were set by the client?
Yes, sure. Hello, everyone. So we, as Katrina said, we had actually prepared a retrofit assessment before actually having and had initial discussions on what to best do with the project. But I think what's key and what's really special about this project is that as designers, we were asked to showcase best practices in many levels, and that's actually, it's really a dream job. It is a dream job. I always worked on retrofit, and this was actually a dream job, to really just pick all the best practice standards and strategies. So that's what we did. And with that also came along with lots of challenges because we had lots of limitations. But overall, we went for NFIT to actually ensure in practice low operational carbon. We also targeted REX standards for low embodied carbon. We also embedded in our methodologies off-site construction and the use of natural materials. So it's really a showcase and, well, of course, implemented low carbon technologies as well. So showcasing best practices in general.
Thanks, Barbara. I should have said, sorry, I will ask a few questions to the panel, and then you'll have your opportunity to ask some questions as well. Devinda, I want to ask you, how is the programme approach different to other kind of standard contracts?
I think that for this project it was kind of fairly standard in terms of it was a traditional contract. There was a design stage that led to a tender stage then to construction. So it's not that it was necessarily kind of unusual in that way, but I guess that it was somewhat accelerated, and there was a lot of kind of collaboration with ecosystems fairly early on to help sort of detail the design period early enough so that when we could get started, we could meet that sort of time frame as well. So yeah, I think that was maybe how I thought the programme.
Thank you. And then I suppose this is really for yourself, Gerry, Matt, and Cormac, so all from a different perspective. Can you tell us about the innovative systems that are deployed and how you've found the process in integrating these? Matt, you want to kick it off?
Yeah,
Go
looks
for
like
it.
I'm kicking off. Hi, everyone. Yeah, so if I talk about the external facade panels, so these used our homegrown mass timber, so CLT, as the main structural panel, behind which we then integrated an airtight membrane, which, this was the first project for us to have to go through the PassivHaus certification process, which was great. We normally work with those characteristics in mind, so the build system that we would normally do would adhere to that, but this involved some extra detailing, which was really beneficial from our perspective, and also beneficial to understand the methodology and bring that to it. But we have these large format panels, which what was really exciting here was that those were manufactured in the what is now the Centre for Mass Timber Manufacture in the building opposite. So manufactured there, and the secondary manufacture of the adding of the James Jones I-beams and the Indie Nature insulation and the external sheathing board and cladding was then all done at the facility there opposite as well, which was an exciting way to do off-site, on-site, and to also bring forward the skills for that. I guess in addition to that, we were bringing the panels to site and installing them on as vertical panels. So we've done a lot of work with horizontal panels previously. This was an opportunity to shift that panel orientation into a vertical axis. So the tallest of the panels was 10.8 meters tall, done as a single element. And the format of the panels is up to 3.3 meters wide. So with that being a very enhanced panel with the external cladding on, it meant that, you know, on a crane install day, I think the maximum number of panels we installed in the day was 8 or 10. Okay. So that allows you to make, you know, really significant progress and transformation of the building shell in one hit.
Brilliant, thank you. Cormac, before I come to you, Barbara, do you want to talk a little bit about the reducing of the energy demand and the system in the project?
Yes, sure. So after doing, something that it was key for this project as well is that we had a relatively good idea of what the main issues were before we started to prepare our retrofit designs. We did some testing. We knew what the main issues were, so we invested our energy and capitals to tackle those main issues. Airtightness was by far the main issue, and because we basically realized how bad that was, we ended up deciding that to have an efficient building, we had to strip most of the existing skin or envelope off. So we focused on, with that strategy, we knew we could focus on highly insulating panels, which consists of CLT, JGI joist, filled with natural materials, with hemp insulation, and partly hemp and partly warm cell, highly insulated windows and doors, and off-site also built ceiling, and we kept the ground floor as it is, a solid concrete floor, which will be insulated in next phases. But overall, we knew what the main issues were. We based our design on in situ evidence, and the idea is to monitor it again, to continue monitoring the building to know how this performs.
Thanks, Barbara. And Cormac, could you tell us a little bit about the system that's been adopted, the innovation behind it, and yeah, just in terms that we can kind of all understand, because every time I have a question.
No, fair play. We came to the party quite late, in all honesty. The consultant had already proposed a water-to-water heat pump system for the building. However, a lot of you will know a water-to-water system would involve boreholes or ground loops to feed the ground source heat pump. However, what they were proposing was a PVT system. So what we actually have now installed at Best Lab is a PVT. So the PV, standard generation, 450 watts a panel feeding into the system. But at the same time, we have a network of piping that sits below there that generates the brine for the ground source unit. Now, it's something that's been done previously in the UK. We have University of West London has quite a large system on their buildings. However, what we wanted to do here and what the proposal was to have an air source heat pump essentially as a secondary heat source. So this is the first PVT hybrid ground source, air source heat pump system in the UK. So you can see that there's innovation being put forward. What you're doing is creating a fuel source for the ground source heat pump simply by having PV panels on your roof. So you get an improvement in PV production because you're taking some of the heat away from the panels. Often people think when it's 30 degrees outside, lovely and sunny, that their PV will be producing lots of energy. However, they tend to drop off when they overheat. So that's avoided in this system, but it also saves the capital costs of land required for ground loops or boreholes. So, my understanding is that there's a lot of talk around sustainability and scalability. And with regards to the heating system and hot water delivery system that's been put into Best, it certainly is very, very scalable.
Thank you, Cormac. Gerry, from a contractor's perspective, what would you say about, deploying these innovative systems into the build? What were the kind of challenges that your team were faced with, and how did you kind of progress with integrating these?
Yeah, thanks. We had an early agreement that I would avoid all the technical questions, which I think is actually a good point David raised earlier in his presentation about you don't have to be an expert, you just have to have the experts around you. The tender that came in, and Barbara mentioned it being a perfect project for them. For us, the tender was a if Carlsberg did tenders moment, because a client deeply entrenched in sustainability, a tender that, whilst single stage competitive tender, there was a very significant emphasis on partnering and a significant emphasis on collaboration. So that collaboration for us with the team around us today was key to the project and the programme. Matt's system, in terms of it being manufactured off-site, allowed the programme to have almost two independent critical paths, the external envelope and the internal fit-out portion. So that allowed us, in terms of any challenges, technical challenges that the building throws up, which retrofits always do, it allowed us that time to navigate our way through that. And then pulling the team together early, it allowed us to do that. From a contractor's perspective, I think the team are all fed up hearing me talking about procurement and talking about, as Rachel used the point earlier, the race to the bottom. The race to the bottom is single-stage tendering and a significant focus on cost. Collaboration allows us to see past that, and it allows us to, NEBA, where 5 stages removed from the client, by the time you go past client, main contractor, subcontractor, sub of the subcontractor, material supplier, ultimately the product that's designed by NEBA. Early involvement is key to that, early involvement from all the parties getting together to solve problems early in these types of projects.
Thank you, Gerry, that's really brilliant. Devinda, what would you consider to be a predominant challenge within this project, kind of different to other projects, and how did you handle it, and how was that then maybe successful or not? Hopefully it was.
I think the challenges that came up, some of them were around, like you'd said, Gerry, like the existing building itself, like things that kind of come up with any kind of retrofit job, even if it's not necessarily aiming for interfit. But I think it was the catching of that, the sort of, we were all quite engaged in sort of getting out onto site quite regularly, kind of, and coming up with solutions together. I think there was a lot of kind of collaborative effort across the board to try and mitigate these kind of issues as and when they came together. And instead of, in some other kinds of projects, maybe trying to pin blame or try to, you know, sort of extend time to sort of delay things. So I think there was like a real effort from everyone to try and manage solutions or manage problems together. And I think that made a big difference in being able to achieve this as well as it has and within the time that we had.
Great, thank you. Matt, and Gerry did kind of slightly touch on this, but from your perspective, what could you have been done differently to improve the process or the delivery programme? What things would you think about, or what was done differently for this particular project?
Yeah, I suppose maybe rather than doing something different if we were to do it again, I think this is a project offered a few unique opportunities for us. So the fact that the secondary manufacture, i.e., you know, going beyond just production of the CLT panels, which happens at the facility at best. Anyway, normally we would then do the enhancement, the secondary manufacture up in our facility in Invergordon, but there was the opportunity here to do that in Blantyre at best. Which was great to do because it's, you know, that's an opportunity to trial decentralized manufacture. You know, as we scale that you know, is likely to be something we would want to do, and it allowed for creating new skills, you know, supporting folk to get up to speed with what our manufacturing processes are and things. That, of course, came with requisite inherent challenges around that because, you know, on a program where, you know, quality is key, time is finite, and budget's finite. You know, doing that new learning and bringing together, you know, new individuals and stakeholders to participate in that certainly provided some tensions and some challenges. Yep. But if we were to do it again, then we get to build upon the successful outcome from that. Is that okay?
Yeah, that's brilliant, thank you. I've just got one or two more questions before we go to the panel, but I'll maybe come back to the last question, Barbara, which is for you. I'll come back at the end. But Gerry, just quickly, what lessons from this programme will your organisation take forward for future activities?
I think I touched on a lot of that earlier in terms of the lessons learned. Train and explain is something I've been using quite a lot. Unfortunately, as an industry, speed is the dominant driver a lot of the time for various reasons. Funding, majority, completion date, and the requirements is to keep that completion date as close to when you start to use the building for whatever reason you're using it. So, unfortunately, speed is the challenge when it comes to quality. We trained our people, and that was a really important part, but when I say explain, it's about getting them to understand, you know, in terms of PassivHaus and ENERFit standards and the importance of every little bit of quality, that, you know, slowing down, taking that extra little bit of time to do it properly, to do it well. We did have the benefit, of course, that Ecosystems were doing it in a controlled environment, an off-site manufactured environment. So from our perspective, it's about upskilling the workforce to get them to understand that cutting that corner to save an extra 10 minutes can cost a lot later down the line when it's not done right. So that's been a really important part for us as a business in terms of training, not just the operatives that are actually installing it, but training the team that are managing the projects and actually bringing the projects into the business from a tendering point of view.
Thanks, Gerry. That's so important as well when we talk about the things this morning around unintended consequences going to take. We've got some questions now in our Slido. So Angus has asked, how has retrofit reduced the building's energy consumption, and how does this compare to embodied energy carbon? Barbara.
So I talked a little bit about the fabric and how I also talked about the low carbon systems. So we had a strategy for the fabric. We focused on airtightness because we believe that was one of the key aspects to reduce energy consumption. But something interesting and something that really gave us certainties, given the very limited times and all the constraints that we had for the project, something that allowed us to de-risk and make sure that we would reduce energy consumption, is that we modeled this in a lot of, we modeled it in detail from very early stages of the project. So we knew what each of the measures, what each of the insulation materials, panels, air tightness, and etc. was actually impacting in terms of energy consumption. And we did the same for embodied carbon. So we modeled the embodied carbon for the building, modeled different scenarios, and that allowed us to inform the client and the rest of the design team how these different measures and strategies were comparing. And we had benchmarks, we had numbers, we modeled also thermal bridgings and etc. So I think modeling was a key aspect. Modeling, monitoring, and measuring during construction was a key aspect to actually make this work.
Thanks, Barbara. Sorry, the next question is, so why use cross-laminated timber, Matt? When timber frame might be more resource efficient.
Yeah, so it's quite a simple equation from my point of view. So it's certainly true that because we have James Jones joists in external to the CLT, that we could have eliminated the CLT layer and without addition of much additional timber over and above that. So from an overall resource efficiency, if we look at the timber alone, then certainly we could have reduced the amount of timber that we'd used. And whilst we're a proponent for use of mass timber, we're also very conscious to be as resource efficient as we can with that resource. But had we removed the CLT layer, we'd have had to replace that with a sheathing layer and then probably a couple of layers of either thermocell or plasterboard or whatever material would have been requisite to achieve the fire performance requirements. Those come obviously with a different embodied carbon burden on the project. And moreover, what we benefit from the use of CLT is that we get that really timber-rich environment at the end of that. So we get all of the biophilic benefits that come from the use of timber. So when we take a look at that overall, for me, that very effectively answers the question about is it appropriate to use the CLT in that instance. We have done analysis from a cost, carbon, and also weight perspective, and for us, the CLT approach has won out on all three of those metrics.
Thanks, Matt. Just want to stay on you for one more question and then we'll move on. But Scott's asking, what other non-domestic building types would suit this type of off-site panelised approach to retrofit? You have some examples? Yeah, sure. I mean, any non-domestic scenario that you'd like to imagine, I'm sure it would suit well. But we have been fortunate to do a retrofit, panelised retrofit facade replacement on a school down in Hampshire. That's a Scholar school, so that was a 1970s typology where it is built on as a system build. And what's great with that, very similar to this, you've got a structural steel frame that's still very much fit for purpose, a building which fundamentally has the space standards and the environment around it that's beneficial, and rather than knock down and replace, we've got the opportunity to replace the facade, because the original facade would have been uninsulated, single glazed, and all of that. So we've done it on that, but really I don't think there's a limitation on what other projects this could be delivered to, and I think the flexibility that it affords and the speed and minimisation of disruption is really key. Minimising that disruption within the school environment was really fundamental. We were able to deliver sections of facade over a weekend with a mobile tower crane, so the school was, remained in use throughout that transformation process, and the overall program was reduced from 52 weeks to 40 weeks. So yeah, any project you'd like to imagine. Brilliant, thanks, Matt. We'll look at the cost. How much extra cost did How much extra did it cost to a standard retrofit? So we were funded 1.2 million, which was 80% of the project, and additional 20%. We didn't do cost comparison to the retrofit insulation measures. I don't know if we have that specific statistic, but what we can say is it would not have been possible knowing like what we know about how we had to approach that in terms of time of a programme and cost in that sense, in terms of that would have had escalating costs, overrun programme timescales because of using the innovative off-site solutions. I don't know, Barbara, if you want to add anything to
Yeah,
that?
it's difficult to actually understand what a typical refurbishment is, because you kind of start to compare apples with something else and not apples with apples. But we didn't really compare it to what standard is. The aim of the project was really to target the best practices in the market. We did try to keep as much of the original building as possible. That's something that we did explore, and we looked at different scenarios, but we didn't look at that. But something that I could say on cost is that, and in the context of scale, is that something that is also key about this project is that it's a phased approach. And NFIT and other best practice standards allow you to, for example, the ACB as well, allow you to approach this on a step-by-step and phased approach. So all of this looks great, the client was great, the team was great, but this might not be necessarily replicable in the same way. But what it is important and key in terms of cost is that you can plan this.
Yeah.
You can hire a specialist team to have a 5-year plan, 10-year plan, 2-year plan to be able to implement this at scale.
Thank you, Barbara. Matt wants to
Yeah,
come in there. Yeah.
Just quickly, if it's helpful, I mean, on cost, that the school retrofit that I mentioned, that had to compete on cost. And whilst the panelised system in isolation was more expensive than a retrofit, panelised approach would have been, retrofit approach would have been, when the overall programme was taken into consideration, the reduction in prelims meant that actually we achieved cost neutrality with conventional.
That's brilliant. Thank you, Matt. One question that has just come up, are there any areas you think could have been done better? So either performance or construction, Gerry, I don't know if there's something you want to thinking about more around the programme sequencing, construction, if you were to undertake it again.
Not to repeat myself, I suppose, but ultimately earlier involvement, particularly the challenges internally to the building, the ceiling, which the design essentially didn't work. So when we engaged with the supply chain, we actually, it was almost a lovely moment in the project when it showed true collaboration all the way to the actual joiners that were installing the ceiling, inputting into how do we build this, how do we make it work. Now, this project had the benefit, as I said earlier, that it had 2 critical paths, so we weren't delaying the overall job by taking the time to solve that issue. We ended up actually building the ceiling in an inverted way, which was a challenge that had to be. It was also almost a mini version of the external facade, where we built cassettes on the ground to the depth required and then offered them up in a panelised system. So that was an example perhaps of something that if we had been engaged earlier all the way through the supply chain, we could have perhaps reached that buildability part earlier, and then there might have even been an improvement in programme, yep, as opposed to actually just achieving the programme.
Thanks, Gerry. Cormac, from your perspective, how did you find any difficulties around supply chain for some of the specialist equipment installed?
It was all in stock.
Well, that's a bonus.
No, I mean, we are a Swedish manufacturer and we hold stock in the UK, so actually we were, I guess in this circumstance, lucky that everything was there that we required to do this project. And just sort of reverting back to one of the previous questions, in terms of the system that's been fitted here, it's probably cost zero versus doing a sort of standard water-to-water heat pump on a building. I guess the only addition cost-wise would be the addition of the air source heat pump as a sort of secondary bit of kit. But in terms of supply chain, no, we as a European manufacturer find it quite lucky. We don't have to wait for product to come from the other side of the world. It's only Sweden we're talking about, so actually the facility, if it's not in stock or not available, it can be pulled through very quickly.
Thanks, Cormac. I don't know if anyone else wants to kind of contribute to that question around supply chain or I think it's gone off my off my chart now.
So the supply chain, again, we're very engaged in the project. Back to my point about kind of train and explain the project, explain why we were doing the project. So actually we had a real engagement with the supply chain in terms of using their product and being able to advertise what their product can do when it's incorporated into such a project. So I think we benefited from that, and the design team benefited from that as well along the way.
Thanks, Gerry. A couple more, I think we've got time for 2 more questions. Rachel's asked, can you describe how you manage the zoning of the building, interfaces between high-performing heated areas and then the colder spaces? Barbara asks.
I mean, it's a relatively straightforward design. It's mainly offices, and the area that hasn't been retrofitted, and it's by colder spaces. I don't know what you mean, but I would say it's mainly office spaces what we retrofit. The factory, it's not part of the retrofit project, so the areas, the zoning, we did zone it in I think it was 4 zones, but the temperature difference is not so much. One of the things that was had to be planned very carefully, it's the phased approach and how parts of the building that would not be improved in the first phase, how that would how that had to plan carefully, embedded in a stage approach to not affect the function of the building until the phase 2 would be installed. So I think that's something to consider. But in terms of zoning, it's relatively straightforward.
Thanks, Barbara. I'm just going to finish off with a question to each panelist. So we're thinking about scaling solutions. This system's developed, exists. Matt, you've deployed it in many building types. But I think what we've really learned from this project, and us being best as well, is the journey from kind of inception of the project right through, and the importance of working together, the collaboration, the cultural change, the upskilling, the utilising innovative solutions, and really being able to disseminate that as a learning tool for industry. But if we're for the audience to take something away, and if they're thinking about programming and how they scale and transition to decarbonisation, what have you learned from this project that you would as a takeaway? And if I can just go around to everybody.
I'll start then. So I think there are things that you can do actually for free. For example, gather information for your estates, for your buildings, for your for whatever you have on maintenance requirements. Make sure that you have all the information there for once the retrofit project begins. It's available for the designers. That can take a good amount of time, and that information is sometimes not available. So start gathering information, linking maintenance with improvement. It's key. And I would say once you do that, try to measure buildings as much as you can. Sensors became more affordable. We discussed earlier that there are scalable ways of measuring buildings, so try to measure and know your buildings as much as you can. And the next step, it's have a retrofit plan ready, because if you can't do retrofit, or you can't go ahead with a project as complex as this, that's fine, but you can plan it, and there are specialists out there. There are hubs with really good knowledge where you can start learning about retrofit, and you can hire a team to have a retrofit plan in place for when circumstances, budget, funding, it's available. Because one of the big challenge in this project was that, and that's applicable to many other projects, we had a year to actually develop the design and finish on site. So you do have to have a relatively good idea of what's wrong with your buildings, what's actually going well, because we also learned that buildings sometimes perform better than what you're expecting. So know your buildings, have a plan, and try to have that plan as developed as possible for when things are ready to go inside.
Excellent, thank you, Barbara. Cormac, is there anything that you would take away, or is it for the takeaway for the audience?
The advice I guess I would be inclined to give is that to have installation teams and manufacturers involved earlier on in the project. Great that we can do modelling and design on paper, for want of a better word, but actually when you get down to the nitty-gritty of actually doing the job and doing the project, most manufacturers and certainly the installation team are more than happy to be involved because they can spot possible issues, slightly better ways of doing something, and that will give benefit to the project in the longer term. So, early involvement is something I would make a recommendation to everybody in the room.
Brilliant, thank you. Matt? Oh, sorry, I didn't know you had the mic.
Yeah, I would say, be bold and be brave, but know that the bravery required is significantly reduced by the fact that this project's been delivered and demonstrates a success of this as an approach, and know that that bravery and boldness will be rewarded because you'll have a really high performance and really healthy build system and all the biophilic benefits that come with it.
Excellent, thank you. Devinda?
I think just following on from Barbara's point about the data gathering of your existing buildings, I think that's really crucial to then know what specifically can be kind of improved earlier on. And then upskilling yourself, I guess, even like with the end users, the kind of estate management team, whoever it might be, if they can sort of have an understanding of what systems might be kind of useful for them, and this kind of operation side of that as well. I think that probably makes it a bit more successful when it's been delivered and the ongoing kind of performance of that long term.
Thank you. Gerry?
Thanks. As a main contractor, I often have been saying over the past year that procurement and asking to be involved early and potentially negotiate or not have a competitive tender is like a turkey voting for Christmas. Of course I'm going to say that, but as Devinder said earlier, these types of projects rely on collaboration, and for us, when you meet a problem, which you most likely will in a retrofit job, the last thing you need is parties disappearing off to trenches, because at that point you're going to incur time and you're going to incur costs. So the early involvement, the collaboration allows for that more, mature approach to these things. So for us, that would be key for us from a main contractor's perspective.
Excellent, thank you. Thank you so much to our panellists. Thank you for the project team that have brought this project and realised it, and Bess cannot be more thankful for that. So just I want to give everyone the panellists a round of applause.